All right, back to applications of variation. So we're looking for keywords either directly or inversely, and it tells us the weight of a certain material varies directly with the surface area of that material. So let's use W for weight, and direct is just straight multiplication. I'm going to use S for surface area. If 8 square feet weighs half a pound, how much will 12 square feet weigh? So our surface area is 8 and our weight is 1/2. Actually, I'm going to use 1/2 because I think it'll be easier to do the fraction work. Kind of. So I'm solving for K. I'm going to divide by 8, but I'm going to do that as a reciprocal because on the left-hand side I get my fraction of 1/16. So K is equal to 1/16. So my variation equation is y equals 1/16s. All right, so now we want to know how much will 12 square feet weigh. So that'll reduce to, it looks like 3/4. And it's in pounds, so pounds. Okay, next one. As you read the next one, you notice that the word directly and inversely don't appear. That's because this is a linear equation. Total cost of making bracelets is $210. That's the fixed cost, probably equipment, whatever, plus $1.75 for each bracelet made. Express the total cost of producing bracelets as a function of the number of bracelets produced, X. So remember, they don't say it, but this is a linear equation. So the nice thing is they give us the slope and the y-intercept. I don't have to do a whole lot of solving. I just fill in my numbers to our linear equation. 210, that's the fixed cost. That's our B. And how much is it per bracelet? It's $1.75. So M equals $1.75, which gives us the equation. They want us to use C instead of Y. So C equals 1.75x, that's the number of bracelets, plus $210. Okay, so there's our function. And on XYZ, this is a 3-part problem. There's our function. And they asked us to express the total cost. Oh, actually, we're done with this. They didn't ask us to use the equation at all. Okay, on example 10, same idea. It is a linear equation. They actually give us that hint here. They're giving us 2 xy points, all right? So we're going to calculate our slope and then use point slope to get the equation on the line. So they're telling us the number of years, they want it in terms of the number of years. That makes that x. I'm going to use the variable t in the end, but I'm just going to label these x1, y1, x2, y2, because that's what looks familiar in my slope equation. Doing the math, 650 minus 1100 is going to give me negative 450. And that's going to be over 3. So my slope is going to be negative 150. All right, now we just need an equation of a line. Y minus y1 equals m. You use point slope, it's faster than y equals mx plus b, unless you already know your slope. And your y-intercept. All right, so I'm going to use y1, my slope, and x1. Slope is minus 150. X1 is 1. So my final equation, now I need a little more room. So we get y, I'm going to add 1100 to the right-hand side to save space, equals negative 150x plus 150 plus 1100. In y-intercept or slope-intercept form, that looks about right. And if it's not right, you guys will tell me. Okay, using the function a, find the original purchase price. So let's go back and change that to t. Because they asked for it in t, you're going to have to enter t. What is the original purchase price? Years after purchase. So we are looking for the original purchase price, which would be at year 0. So y of 0 is equal to negative 150 times 0 plus 1250. So the original purchase price was $1,250. Assuming the value of the computer is a linear function, well, we've been doing that all along. When will the computer be worth $300? So 300 is equal to negative 150 times t plus 1250. So we just plug in the 300 for the cost, the price, and it looks like we get 900 equals negative 150. Sorry, that's a negative 950t. And it looks like 150 goes into 900. 150 goes into 3 twice. 2 times 3 is, it looks like it goes in there 6 times. So t equals 6 years. And that's about as long as a computer will last. Last example, a piece of equipment costs $205 to manufacture in 2012. Since then, its manufacturing cost has decreased by $11.30 per year. So again, this is a nice linear equation. They've given us the slope, and they've given us the y-intercept. And t is the number of years since 2012. Find a linear function that gives the manufacturing costs. C of t is equal to 11.3 times t plus 205. If the trend continues, what's the cost of manufacturing the equipment in 2017? Well, 2017 minus 2012 is going to give me 5. So we're just going to plug in a 5. And as I'm working this part of the problem, I realized that they said that that cost per year decreases. It goes down. So that should be a negative. All right, corrected that. So when I do the calculations, I'll get negative 56.5 plus 205. When I put those two together, I get $148.50. So the $205 will decrease to $148.50. When will the manufacturing cost of the equipment reach $80.70? Okay, so this is our cost. It goes in for Y, or for C. And negative 11.3 times T plus 205. So solving steps. All right, 8070 minus 205 is negative 124.3. do some division. And we get the final answer of 11 years. And what year did we start counting in? I think 2012 plus 11. 2023. All right, see you in class.